In this lesson, we'll look at how to initiate a Revit family element, as well as how to control a family type and instance parameters in Dynamo for Revit. Since we'll be automating the placement of Revit families and setting parameters, I'm going to create a new project file. With Revit loaded, navigate to the Insert tab and select Load Family. Select the column type from the provided dataset. With the family now loaded into our project document, we can select Edit Type from the Properties windows. Select the family, then Edit Site, and make changes to the type and dimension of the column. I'm going to close the Edit Type window and return to the Properties palette. There is an additional instance parameter to find the height of the column. Change the value of an instance property affects only the element in your selection set, or the element you are about to place. Let's place 3 column type into the property project document. Notice that each instance has a predefined width and depth. We will use Dynamo to automate the placement of these family types based on the proximity to a point. Closer to the point will have a larger width and depth dimension, and furthest will be narrower. I will now select the columns that I had placed into the project document and delete them by pressing Delete key. Let's launch Dynamo from the Add-in tab. In Dynamo, let's search for the Family Types node. The Family Type node will look into the current record document and select all family types available. Using the drop-down browse to the A.3 point to Computational Logic column type. Now add 2 more family types node of the workspace and select type 2 and 3. We'll now create a list of family types by adding a list created node to the workspace. Clicking the plus icon to add 2 more import ports and connect the family types 1, 2, and 3 to the list. We will now add a get item at index and integer slider of the workspace. This will allow us to select one of the family type from which we created. Note that the max value of the integer slider should correspond to the max value index of our list created. Connect the output of the integer slider to the input port index on the list get item at the index node. Using the rectangle at the bottom right corner of the list get item at index node will expand its output. Making changes to the integer sliders will now dynamically result in an alternate family type being selected. To automate the placement of this family type 1, I will search for a family instance by point node. This node is located in the Revit family instance, created category. Take the output of the get items at the index node and connect it to the family symbol input port of the family instance by point node. The second input port requires a point at a point by coordinate node to the workspace to define the origin of the family instance. I will use a number node to define both the x and y coordinates. Let's see the result of this operation in Revit. Making changes to the integer slider results on a different family instance being placed. I will now make a modification to define a sequence of values. You right-clicking on my points by coordinates, I will change the lacing to cross products. Once again, I will make changes to my integer slider to see the result automated in Revenue in order to pick and choose which of the family types are placed. I will need to create a point that will work as a attractors or a structural loading point to determine the distance and to place the type based on the proximity. To this, we will start by adding another point by coordinates node to the workspace. Use the number node to define the inputs for x and y. The second point by coordinates node will be a attractor. In order to determine the proximity of each of our points coming from our grid, I will search for a geometry distance to node and connect the output of my grid to the geometry input of the geometry distance to node. I will then take the output of my lower point into the energy input to view the distance. I will click the rectangle in the bottom right corner of my geometry distance to node. We have now computed distance from each center point to the attractor, but to use these values to get an item from a list, we will need to remap the values. We have now computed the distance from each center point to the attractor. But to use this value to get an item from a list, we will need to remap the value returned to the search field in the node library. I will type remap and add the remap range node to the workspace. The remap range now will take a current value and remap it within a target domain. In this case, our target domain is between 0 and the count value of our list. This corresponds to the value we see here in our engineer slider. I would like to remap the distance to a domain between 0 and the new max. We will use the number node to specify a new minimum. The new maximum must be computed from our list. Create a node. I will search the library by scrolling down through the category related to actions within this category. We will see there was a node called count which get the number of items stored in a given list. We will connect the output of our let's create to the input of list count. Notice that the output is 1 greater than the maximum value specified in our integer slider. In order for us to remap the distance to a selected range, we will need to subtract a small amount from this value and select the node floor to run down to the closest integers. I will start by going back to my node library and from operator select -. From the list count, I will subtract 0.0, 0, 1. Subtracting a small amount from the list count will allow me then run down to the closest integers. To view the output of the remap range, I will click on the rectangle at the bottom right corner of the node. You can see that these values are now between 0 and 2.999. We can use the float node to return the first integer smaller than the current value. Take a look at the output of this and comparing it to the list on the left. We will see that now 2.99 returns an integers of 2. The output of the float node will now replace the index input or to get item at index. Now, let's verify that this definition is correctly automating this task in Revit. Make a change to the load point and Dynamo will automate the placement of the family type. To make columns larger diameters correspond to the closest distance, we will subtract the output of the rim at the ranges from the initial subtraction node. Lastly, we will need to add an element set parameters by name to the workspace. This node will take a specified parameter's name and allow you to quickly redefine the associate value for each family instance. Connect the output of the family instance by point node to the element input of the set parameters by name node. To define the parameter name, we will add a string node. Selecting a column in Revit will allow us to see the property or parameter we would like to interface is title height connect to this output to the input port parameters. Using a number node, I would new As you can see, this definition efficiently automates the selections, placement, and parameters manipulations of a collection of Revit family elements.